So question 3, given that we have points at A at 1, -1, B at 3, -1, C at 1, -6, they form triangle ABC, and D at 4, 1, E at 2, 1, and F at 4, 6, form triangle DEF. Prove that triangle ABC is congruent to triangle DEF. Read the following proof for this problem carefully and then follow the instructions. So use the blank to find the distance of AB, the distance of BC, the distance of AC, the distance of DE, the distance of EF, and the distance of DF. So I'm looking at this and seeing how it's read. This is read as the distance from A to B, so we're going to be using a distance formula to find those distances since it is not given. Show that AB equals blank, which equals blank, and BC equals blank, which equals blank, and AC equals blank, which equals blank. Okay, those are a lot of blanks through that, so I guess we'll figure out what's going on there. Use the definition of blank to show that each pair of congruent lengths represents a pair of blank segments. Use the blank to state that triangle ABC is congruent to triangle DEF. So since it's going off of all of the side lengths, and that is for blank 10, all of the side lengths means that they're going to be using side congruence postulate. So that's just something that I picked up, is noticing that they are comparing all of the side lengths for all of the triangles. So it's also talking about congruent lengths represent a pair of congruent segments. So blank 8 and blank 9, let's see the options, EF 5, segment of DE, side angle side congruence, distance formula congruence, perpendicular segments, or congruent. Okay, so I'm going to think of congruent and segments. So use the definition of congruent to show that each pair of congruent lengths represents a pair of congruent segments. Well, pair of congruent segments sounds correct, so blank 9 is congruent. So we have congruent. And use the definition of congruence to show that each pair of congruent lengths represent a pair of congruent segments. So we are going to be using congruence. Where did it go? Congruence. Blank 2, 3, 4, 5, 6, and 7. Now our options are going to be numbers and the corresponding segment length. So we have to know which segments are going to be corresponding to which segments, and this is how I know. So they're listing it off as triangle ABC. This is listing it off as triangle DEF. So triangle ABC and triangle DEF. Actually, let me do this just to show you what I'm talking about. Okay, just because A starts here, it does not mean that it is corresponding to whichever label is listed in that position right there. Because A is the first label in this triangle, it's going to correspond to the first label or the first point in the next triangle. So A actually corresponds to point D. Point B corresponds to point E. And point C corresponds to point F. So C and F correspond with each other. So corresponding side lengths are going to go between corresponding points. So A to B, that side length, is going to be corresponding to the side length that goes from D to E because those are its corresponding points. Side length B to C is going to be corresponding from side length E to F because those are its corresponding points. And side length C to A is going to be corresponding to side length D to F. So it's based on how it's listed. So now we're looking at segment A, distance of AB is equal to blank. Well, distance of AB is corresponding to distance of DE, so blank 2 is going to be distance of DE, which is represented with the line not over it. And then the 3 is going to tell us how long it is. So let's find out the distance of DE. Or AB. So since A is listed first, A would be our x1, y1, B would be our x2, y2. So again, conceptually it's horizontal distance, which is the difference between our x coordinates, so 3 minus 1. Vertical distance is the difference between our y coordinates, so -1 minus -1. Minus a negative, just change to just an addition, and then jump over to our calculator and you type in the square root parentheses 3 minus 1 parentheses x to the y squared plus parentheses -1 plus 1 close parentheses x to the y squared, close your parentheses, and that equals 2. So if you come back over here, blank 3 is going to be 2. And then we'll go to blank 4 and blank 5. Blank 4, segment BC is corresponding to segment EF. So blank 4 is going to be segment EF, which we have these. Okay, so segment blank 4 is segment EF because it's its corresponding segment. And then we're going to find what the distance is for that. So now E is going to be our, now E is going to be our x1, y1, and F is going to be x2, y2. So if we, again, x2 is 4 minus x1 is 2, and y2 minus y1 is 6 minus 1. So then we're going to jump over to our calculator again. Square root of parentheses 4 minus 2, close parentheses x to the y squared, plus close parentheses 6 minus 1, close parentheses x to the y squared. What does that equal? 5.38. So if we jump back to blank 5, notice that it doesn't have a 5.38. We have square root of 29. So let's check that. So what's the square root of 29? That comes out to be exactly what it was. So it equals 5.38, which is equal to the square root of 29. So that's how I'd use the calculator to help me solve that. So blank 5 is square root of 29, and then if we jump back up here, segment AC, or the distance of AC, is equal to blank. So the distance of AC, its corresponding side is going to be the distance of DF. So blank 6 is going to be the distance of DF, the corresponding side, and let's find what that is. So now that we're finding it, it is going to be A to C. So A is our x1, y1. C is our x2, y2. And so when we use our distance formula, our x2 is now 1 minus x1 is 1. y2, or our vertical distance, is going to be -6 minus -1. -6 minus -1 will simplify to -6 plus 1. So jump over to calculator, you type in the square root of parentheses 1 minus 1, squared plus parentheses -6 minus plus 1 close parentheses, that's being squared, and that's going to come out to be 5. So now we can jump back over here, and our blank 7 is going to be 5. Use the definition of blank congruence to show that each pair of congruent lengths represents a pair of congruent segments, which is what we had. And by side, 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 we matched corresponding sides. BC is congruent to EF. AB is congruent to DE, which is a corresponding side, and CA is corresponding side is FD, and they are the same length. So that's how I would use my tools to answer this question. I hope that helps.